All right, this is Unit 1, Lesson 1, Key Features of Functions. So my lesson essential question is, how do graphs and equations reveal information about a relationship between two quantities? At the end of this lesson, we'll be able to interpret key features of linear, quadratic, and absolute value functions given an equation or a graph. All right, example 1, understanding domain and range. What are the domain and range of the function defined by y equals x squared minus 3? So the graph represents a function because each input has exactly one output. Okay. So the set of all possible inputs for a relation is called the domain. You can square any real number, so any number can be input for x. The set of all possible outputs for a relation is called the range. The square of a real number is greater than or equal to 0, so the minimum value of y equals x squared minus 3 is 0 minus 3 or negative 3. There are two notations used to represent intervals of numbers like domain and range. So you have set builder notation, which uses a verbal description or an inequality to describe the numbers. So using set builder notation, the domain of this function is x bar, x is a real number. This is read the set of all x such that x is a real number. Using set builder notation, the range of the function is y is greater than or equal to negative 3, which is read the set of all y such that y is greater than or equal to negative 3. You also have interval notation. This is probably one of the most common forms that you'll see in math is interval notation. You'll see set builder, but a lot of times you'll actually see interval notation more often, except when you get into higher level math. Interval notation represents a set of real numbers by the pair of values that are its left minimum and right maximum boundaries. Using interval notation, the domain of the function is negative infinity to infinity. So looking at this graph right here, if I were to continue these lines, they would continue going further and further out on the x values, both positive and negative, which is where we get our domain of negative infinity to infinity. Using interval notation, the range is negative 3, infinity. Notice that this isn't a parentheses, it's actually a bracket. So this means it includes negative 3. So if I look at my graph right here, I can see that the graph actually touches negative 3, y equals negative 3, which is why it's included in my range. So to summarize, the ways in which we can indicate intervals of numbers refer to the table below. So interval notation, I have 3, 4. So all real numbers that are greater than or equal to 3 and less than or equal to 4. So in set builder notation, x is the set of 3 less than or equal to x, less than or equal to 4. Parentheses 3, 4 bracket are all real numbers that are greater than 3 and less than or equal to 4. So again, I have 3 less than x less than or equal to 4. Bracket 3, 4 parentheses, all real numbers that are greater than or equal to 3 and less than 4. So again, here's where that less than or equal sign and the less than sign come in. Both are in parentheses, 3, 4. So I have no equal signs, they're both less than. 3 to infinity, so 3 to infinity, negative infinity to 3, negative infinity to 3, and then negative infinity to infinity, where both are not equal. Anytime you have infinity, you can't use brackets with infinity because it's not an exact number. All right, B. An air tanker flies over forest fires and drops water at a constant rate until its tank is empty. What is the domain and range of the function that represents the volume of water the air tanker can drop in x seconds? So the tank capacity is 8,000 gallons and the water release rate is 400 gallons per second. So the function is f of x equals 400x. The air tanker cannot drop water for a negative number of seconds. So x has to be greater than or equal to 0. The tanker can drop water for a maximum of 8,000 divided by 400, which is 20 seconds. So it carries 8,000 gallons divided by 400 gallons per second, gives us the 20 before running out of water. So x is less than or equal to 20. So the domain is x is a set of 0 less than or equal to x less than or equal to 20, or bracket 0, 20 bracket. The air tanker cannot drop a negative number of gallons and its maximum capacity is 8,000. So the range is the set of for y from 0 less than or equal to y less than or equal to 8,000, because somewhere in between, that's what we need. That's how many gallons of water we could potentially have. So, or bracket 0, 8,000 bracket. All right, so let's try it out. What are the domain and range of each function? Write the domain and range in set builder notation and interval notation. So for letter A, my domain is my x values. So x is a real number. Infinity. So I can put in any number. It's always going to be, it's an absolute value. So y is always going to be positive. My range is y greater than or equal to 0 or bracket 0 infinity. Because my answer is an absolute value, my y value has to be a positive, which is why y has to be greater than or equal to 0. All right, for letter B, I have y equals 6x minus 2x squared. So my domain is x, where x is a real number, which is like saying negative infinity to positive infinity. Of graph, your domain is going to be from negative infinity to positive infinity. My range, so y is less than or equal to 4.5. And then also looks like this. Okay, so when I set and solve, I can factor out an x here, so I get x equals 6 minus 2x, and then I can solve that for 0, and I get 4.5. So that's my maximum. And then, of course, negative infinity, I can substitute any negative number, and I'll get a y value. All right, example 2, find x and y intercepts. So a car starts a journey with a full tank of gas. The equation y equals 16 minus 0.05x relates the number of gallons of gas y left in the tank to the number of miles the car has traveled x. What are the x and y intercepts of the graph of this equation, and what do they represent about the situation? So I'm looking, here's my graph. So a y-intercept is the y-coordinate of a point where the graph intersects the y-axis. The x-intercept is the x-coordinate of the point where a graph intersects the x-axis. So the graph above intersects the x-axis at 320, 0. So the x-intercept is 320. This means that the car can travel 320 miles before it runs out of gas. And the graph intersects the y-axis at 16. So the y-intercept is 16. This means the car has 16 gallons of gas when it starts to trip. What are the x and y intercepts of the graph of y equals the absolute value of x minus 3? So the first thing that I want to do is I actually want to graph this, but you can find that algebraically as well. To find the x-intercepts algebraically, the y-coordinate of an x-intercept is 0. So I substitute in 0 for y and I solve for x. So x equals plus or minus 3. Both 3 and negative 3 are 3 units away from 0, so they have an absolute value of 3. So the x-intercepts of the graph of y equals the absolute value of x minus 3 are negative 3 and 3. The x-intercepts are also the zeros of the function because they are the input values that result in a function output value of 0. So I find the y-intercept algebraically as well. So instead of like up here where I did x and I substituted in 0 for y, for y-intercepts, I'm going to substitute 0 in for x and solve. So y equals the absolute value of x minus 3. So y equals the absolute value of 0 minus 3, which is 0. 0 minus 3 is negative 3. So the y-intercept of the graph of y equals the absolute value of x minus 3 is negative 3. All right, so let's go ahead and try this out. What are the x and y-intercepts of g of x equals 4 minus x squared? So the first thing I'm going to do is I'm going to substitute in 0 for g of x or y. 4 minus x squared. Okay, so this gives me 4 equals negative x squared, which is going to give me, I'm going to do this, so x squared equals 4, and then I'm going to square root both sides. X equals plus or minus 2. So my x-intercepts are 2 and negative 2. Okay, I'm going to do the same thing for my y-intercept. I'm going to substitute in 0 for x. So I have y equals 4 minus 0 squared, which gives me y equals 4. So my y-intercept All right, example 3, identify positive or negative intervals. For what intervals is f of x equal x squared minus 9 positive, and for what intervals is the function negative? So I can use technology to graph the function. So when I'm dealing with positive, so positive is anything above the x-axis. So f of x is greater than 0, which is above the x-axis when x is less than negative 3. So here, less than negative 3, and when x is larger than 3, so greater than 3. So the function is positive at negative infinity to negative 3 and 3 to infinity. Notice that I'm using parentheses and not brackets here. I'm not including the negative 3 and the 3 values because they're actually neutral, neither positive nor negative. Okay, so parentheses indicate that a boundary point is not included. So negative, so if positive was anything above the x-axis, negative is anything below the x-axis. So f of x is less than 0 below the x-axis between the x-intercepts of negative 3 and 3. The function is negative at negative 3, 3. Okay. So the 2 points where they cross the x-axis are neither positive nor negative. They're neutral points. So the function is neither positive nor negative at the x-intercepts of negative 3 and 3. So for what intervals is h of x equal 2x plus 10 positive? So you can see that this is a linear line. So basically it's just a straight line. There's no parabola. I can see that here is my x-intercept. This is neither positive nor negative. Anything above the x-axis is positive, and anything below the x-axis is negative. All right, so that means positive is between negative 5 to infinity, and then negative were negative infinity to negative 5. All right, example number 4, identify where a function increases or decreases. So for what values of x is g of x equal 2 minus the absolute value of x increasing? For what values is it decreasing? So again, I want to go ahead and draw my graph, okay? So increasing, so anytime I'm going from left to right and I'm traveling upwards, that's an increased value. So the value of g of x are increasing on the interval from negative infinity to 0. They're decreasing when they're going down. The values of g of x are decreasing on the interval 0 to infinity. Okay. You can also have a maximum or a minimum point. Your maximum point is the highest point that you're going to be reaching. So the change from increasing to decreasing is called the maximum. The point at which a function changes from decreasing to increasing is called a minimum. This graph has a maximum value of 2 at x equals 0. All right, so let's try it. For what values of x is each function increasing, and for what values of x is it decreasing? So I have f of x equals x squared minus 4x. Okay. So if I look at this, a little bit, okay. So if I'm coming down, so I'm decreasing. Okay, so here, this is my minimum point. So the bottom number is right here at 2, -4. And then turning from there, I'm increasing. So I'm decreasing from -infinity to 2, my x value of 2. And then I'm increasing from 2 to positive infinity. So increasing from 2 to infinity, and then decreasing from -infinity to 2. I can look at the f of x equals -2x minus 3. However, I notice that this is actually a line. It's not going to have an increasing or decreasing. It's not going to have both. It will have one or the other. So in this case, this is a negative slope, so it's a decrease. So it's not increasing on any interval. It is decreasing from -infinity to positive infinity. All right, example 5. Understand average rate of change over an interval. What is the average rate of change of a function y equals f of x over the interval a to b? So first, I have the interval start and the endpoints. That's a and b. Okay, so the interval starts at a value of f of a when x equals a, and the ends at a value of f of b when x equals b. So my total change is this, the f of b, so my y values, and I subtract them, over the interval length of b minus a, which is my x values. So this is the exact same thing as the slope formula, your change of y divided by your change of x. So the average rate of change is your change in your y values divided by your change in your x values. This is the same as the slope of a line segment between the points f, comma f of a and b, comma f of b. Okay. So what do the average rates of change over the intervals -2, 0, 0, 3, and -2, 3 indicate about the given functions? So from -2 to 0, nothing changes. There's no change. From 0 to 3, there's no change. Okay, so this slope, everything's 0. Has the same rate of change, 0 over every interval, a to b. This means it's constant. Okay. For g of x, from -2 to 0, it does change. Okay, so I have -1 minus -2 over 0 minus -2, which is 1/2. So 1/2 is my rate of change. And then for h of x, 0 minus 4, -2 to 0. 0 minus 4 over 0 minus -2, which is -2. I have from 9 to 0 and 3 over 0, it's 3. So this one doesn't have a constant rate of change because over every interval from a to b, this means it's a nonlinear function. So they took each one. Notice here it's all 0. So it's constant, but there's no rate of change. Here it's constant. It's all 1/2. Okay, so it's a linear function. And here it's a nonlinear function. So basically all linear means it's a line. So it's constant and it's a line. Okay. Here it's not constant, so it's not linear. So it's not going to be a straight line. It's a parabola or a hyperbole or something along those lines. All right, let's try it out. What do the average rates of change of the function y equals the absolute value of x plus 2 over the intervals -2, 0, 0, 3, and -2, 3 indicate about the function? Okay, so the first thing that I want to do is actually graph or I could just solve them. So from -2, this point to this point, so -2 to 0, I have -2, 4, and 0, 2. I have the 2 points, -2, 4, and 0, 2. Okay, so when I subtract, I have 2 minus 4, which equals -2, and then I have 0 minus -2, which equals 2. So -2 divided by 2 equals 1. -1. Okay, so that's my first set. The second points from 0 to 3. So 0 was 0, 2, and 3, 5. Okay, so I have 5 minus 2, which is 3, and then 3 minus 0, which equals 3. 3 divided by 3 equals 1. And then my last was over all of these points, so -2, 4, and 3, 5. Okay, so I subtract my y values. Y minus 4 equals 1. 3 minus -2 equals 5. So I get 1/5. So since the rates of change vary, the function is nonlinear. All right, so concept summary. So I have linear, quadratic, absolute value, and constant functions. So linear, it forms a line. Quadratic is a parabola. Absolute value creates this V shape, so it comes to a vertex. And constant is just a straight line. Okay, so I have domains. My domain for a linear function is usually -infinity to infinity, and my range is -infinity to infinity, and it's increasing or decreasing. It's never both. So in this case, it's increasing because it's going from left to right upwards, and that's -infinity to infinity. The x-intercept is 0, and the y-intercept is 0 in this case. Okay, so my quadratic is domain is -infinity to infinity. My range is 0 to infinity. That's the y value. It's increasing from 0 to infinity, but it's decreasing from infinity to 0. Okay, the x-intercept and y-intercept are both 0. My absolute value, my domain, -infinity to positive infinity. My range is 0 to infinity. Notice the bracket. Okay, it's increasing from 0 to infinity and decreasing from infinity to 0, -infinity to 0. The x-intercept and y-intercept are both 0. They meet here at the origin. Okay. For this constant, my constant values are -infinity to positive infinity. My range is going to be 1. That's the only number that it touches. Okay, so there is no x-intercept, and the y-intercept is 1. It never touches the x-axis. All right. And that is the end of Unit 1, Lesson 1.